We left off having modified our Hello World program to incorporate a couple of the escape sequences, most notably the \F, which moves the cursor to the top left corner of the screen and scrolls everything else up off the top of the screen, \N, which creates a new line wherever we want, and the \T, which puts a tab wherever we want. There's also a \B and a \R, but neither of those are going to be things that we use all that much. And by that I mean we're not going to use them at all in this course. Now the question becomes, what happens if we want a literal backslash? Because you can't just put one in there. It ends up creating a mess. So in order to print a literal backslash, we have to tell Java to ignore what the backslash usually does. System.out.println, if I try, here's a backslash. If I try to put a literal backslash in here, then what's going to happen, so you can see how it turns red? What that's saying is that there's no escape sequence here. So what we have to do is put another backslash there. The first one says, hey, ignore what normally happens. And then the second one, which normally would create an escape sequence, instead just gets printed to the screen. And so we could do that. Now the other thing, if we want, since we're using quotation marks at the start and at the end of all of these strings, that means that those quotation marks probably have special purpose. And they do in this case. They open and close what we call a string literal. And when I say a string literal, I mean something just like that, where it's a string that appears literally to the screen. When I say a string, what I really mean is just a piece of text. Now if we want actual quotation marks to appear, we can't just stick them in there willy-nilly. Instead, system.out.println, here is a quotation mark. Put a backslash, then a quotation mark, and then we can end things. And it'll all be okay. So save and quit. We'll compile it all to verify that it works. And we can see right here and right there that first backslash never shows up. Instead it's just these characters. That's what escape sequences do. They replace what something usually does. The backslash normally sets up an escape sequence, and the quotation mark usually either starts or ends a string, and instead replaces it with an alternate behavior. In this case, a literal backslash and a literal quotation mark. Or, up here, instead of a T and then another T, a tab and then another tab. Or right here, instead of an N, a new line. Or, right there at the start, right before the hello world, instead of an F, a form feed. This is the power of our escape sequences and our escape characters. The way that they, and these are things that you'll have to know in order to more finely control the way that things appear on your screen. Now, a thing that we've noticed so far is that when we print things, everything appears exactly as we want it to. But numbers, and this is leading us into some interesting territory, numbers work a little bit differently. And so if we wanted to, we could print a couple of numbers without quotation marks even. So here's a 22 inside quotation marks, and here's a 22 outside of quotation marks. The one inside of quotation marks is text. It works just like a letter, just like anything else that you might see. The ones that don't have quotation marks, those are actual numbers, and we can do math with them, and we'll see that here in just a second. But when we save and quit, we'll see a 22 and then another 22 right below it. And it's not going to look that different to us, but it's going to look a lot different to the Java virtual machine. Here's our first 22. This is the one with quotation marks. This is the one without. They look exactly the same to us, and they look exactly the same when they're on the screen, but what we do with them changes. Which brings up then our next topic, which is data types. When I talk about data types, what I mean is basically the way that we represent information. And you'll remember from the last lecture from the lecture for day 1 that really it's all about that information. It's really all about like the type of information that we have, how we represent it internally, that is to say how we create it, how we do things with it, and then what we do with it. So Java is a strongly typed language, which means that any time we're talking about a piece of data or a piece of information, we have to explicitly say what kind of information it is. And these print statements that we've been using, or in the or even in that time when we just printed a 22 without quotation marks, like in that case, because we've been using literals, because we've been using things that are exactly as they appear, and we can go back into them, we can say, right here, that's an integer, and right here, that's a string, and this is a string. When I say string, all that I really mean is a string of text. That's all that we're talking about. But strings and integers have some different properties, and later we'll talk about more of the data types. Integers are one of the 8 types of primitives, and then strings are a type of object that acts sort of like primitives, but we'll get there. And the way that we do this, the way that we create all of this information, the way that we hold this information, is we can reserve named spaces in memory, which we call variables. And when we create a variable, and we'll get to how to do that in a second, we have to declare the type. That is to say, we have to talk about what type of information we're going to store in that space in memory. We have to give it a name, and we also have to declare the size. And the cool thing about data, the cool thing about variables in Java, is that because Java is a strongly typed language, which means that like when you have data of one type, you can't easily convert it to data of another type without doing a little bit of work. But because we have these strongly typed data types, the size is usually implicit. So right now we're just going to worry about strings and integers. Now strings, we use these to represent alphanumeric text. We can think of these like words on a page. Strings, we create them with phrases like string text equals, this is a string. And then we can print them, and I'll show you how to do that here in just a second. So when we make this, that box is not quite in the right place, sorry. The thing right below that box where it says string, right, that is our type. That is the type of thing that we're making. We're saying that we're making a string, which we call text, to which we assign the value of, this is a string. And then we end with our quotation mark. That equals sign is what we call an assignment operator. It says, take the thing on the right side, which in this case is this is a string, and put it into the thing on the left side, which is our variable called text. And all this really is, this is just a named spot in memory. You can think of it sort of like having like a bucket or a box with a name on it. Like that's the thing that you can think of it as. It's almost as though like you've got a box and you're going to put stuff in it, and then on that box you write a label, and that label tells you what types of things can go in it. And so what we're going to see, again, we're going to create a string, which is just some alphanumeric text. We're going to call that string text, but we can call it whatever we want, and I'll show you that here in just a second, to which we assign the value of, this is a string. And then we can do some stuff with it. Let's play around with that here for just a bit. Let's play around with it. Okay, so we're going to get rid of a couple of these lines, and the way that we're going to do that is using dd, D as in dog. I can just go dd, get rid of that line, dd, 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 and dd. We get into insert mode, and from here we're going to go string name, it's going to be somebody's name, is equal to Throckmorton. And then from this, we can even print to the screen, if we want to, the word Throckmorton pretty easily. And the way that we do that, system.out.println, and then instead of the word Throckmorton, we're just going to put name. And so what's going to happen is we're going to look at whatever the value is here, which in this case is going to be Throckmorton, and we just put it right in there. All that we're doing here is we're saying, hey, Java, take whatever information is stored in the variable called name and print it to the screen. We don't know necessarily what that's going to be, and in the future this is going to be information that we get from our user, but we're going to print it to the screen, and it's going to be pretty cool. So you've saved, we'll compile, and then when we run this, Java, hello world, we're going to see Throckmorton right there. And the thing that I want you to realize is that all of that printing happens with this line of code. Right? That's where it happens. At no point in here do we necessarily tell it exactly what we need to print. We just say, hey, whatever is there, print that. And then we create that up here. And that's one of the powers of variables. And here by the end of today, I'll show you how to take information from the user and then print that information to the screen. We'll be able to do some other things with it too, but for right now we'll be able to just print it to the screen. We'll call that not too far from the end of things. The last thing to know about strings: they're able to hold letters, numbers, spaces, escape characters like we saw before, and any ASCII or Unicode symbol. You just have to be a little creative with how you do it. The other thing that you should know about strings is that when you have numbers in a string, you can't do math to them. They act just like letters on a page. If you want to do math to them, you have to turn them into a dedicated numeric type. And we'll talk about how to do that later in this semester. For right now, though, we can just trust that they're numbers, which means that they don't do math by themselves. We have to do a lot of work in order to make that happen. Alright, when we come back, we'll talk about integers, and we'll play a little bit more with variables before we move on to input. I'll see you in a bit.